A code smell is something in your codebase that may be indicative of a larger problem in the system. I use the word may here because sometimes there is a legitimate reason for code like this to exist. But just like if you smell smoke, you should probably make sure the house isn't on fire. If you come across a code smell, you should take a moment to evaluate it and see if your code needs a bit of care and attention. So here's a few common code smells that you may find in your games, why they can be concerning, and how to fix them. First up is long functions. Long functions are probably one of the most common code smells you'll come across. We all write them from time to time because when you're in the zone, you're just focused on getting the code out and don't want to break that flow. And that's okay, but you should come back to some of your longer functions later and make sure the function is an appropriate length. I don't like to offer specific length recommendations as that just results in an arbitrary cutoff point, but if you've got more than maybe 10 or 20 lines of code in a function, ask yourself if all of the function's code is related to doing a single thing or if things could be broken out a bit. We want to do this so our code is easy to read, easy to maintain, and doesn't contain duplicate code. For instance, a function to calculate how much damage to take shouldn't also take care of everything else related to taking damage, such as modifying the unit's health, updating the UI, playing a sound effect, emitting some particles, and so on. You may want to calculate damage without applying it at some point in your game, such as for the UI, but this function could be incorporated into another general purpose take damage function that coordinates all of these tasks together when it is time to take damage. Another common issue is having long parameter lists for functions, and there's really two main issues with this. The first is that it makes your code less readable, as the function declaration probably doesn't all fit into a single line on your monitor, and the other is that it implies this function may be too complex in one way or another. Maybe the function is trying to do too much or be too generic, branching internally based on what parameters it receives, and therefore needs a lot of parameters that it doesn't need in every invocation. Or maybe the data being passed in really is this complicated, but it should be contained in a data object of some sort to make it easier to pass around, as constantly gathering 10 separate parameters every time you need to call a function is going to add a lot of bulk to your code and open up the potential for data to become out of sync in some way. Next up, let's talk about duplicating code, which is one of the first smells of a poorly organized code base. The first time you copy a few lines around here and there and then later have to make a change to every single occurrence of that code is enough to make you realize how important it is to keep your code singular and unique. If the same code is needed throughout a single script, turn it into a function. If a lot of different objects need the same functionality, ask yourself if they're similar enough to inherit from a shared class, or if not, another option is to create a set of utility functions that house commonly needed code, such as for formatting currency, or to create more components in your application that can be attached to other objects wherever they're needed. Next up is God objects, and I'm going to explain this one with an example. So let's say you've got your player managing their health internally when they heal or take damage, and now you need to update the UI. You skipped my video on the observer pattern, so instead you just create a global object and use it to hold a reference to the player so the UI can ping for health changes every frame. Not exactly elegant, but it works for now. So then you decide you want to show a score based on how many enemies have been killed, so you put a few more references into this global object. Then you need a few helper functions to manage everything and pass some data around, so you add those in, and you might as well make it so you can play a few sound effects from within this object since you're already passing health and enemy data around, and it's easy to catch when something is happening. Plus, you haven't really gotten around to figuring out how to handle audio yet, so really where else would it go? Next thing you know, you've got a God object on your hand. An object with no singular purpose that essentially acts as a dumping ground for data and functions you couldn't decide where to otherwise place. This is problematic, as global data and objects are the singular strands that pile up into spaghetti code, making it difficult to debug and reason about your game's state since significant changes to the data and function calls can occur from anywhere in the app. Plus, once you've gone down this path, it can make it hard to get out of it. Refactoring global data to non-global data generally isn't going to be a trivial task, and the constant temptation of making just one more addition to the existing dumpster fire is going to be hard to resist. There is a time and a place for global objects, but they should be designed with a purpose. So ask questions, study a few design and coding patterns, and don't dump everything into a singular global object. And lastly, for how much I talk about good coding form and the importance of design and coding patterns, it feels important to also take a bit to talk about the other side of the spectrum. Don't over-engineer things. Building a solution that is much more complex and difficult to maintain than what's needed is just as bad and sometimes worse than having an under-engineered solution. Sure, that function may be a bit long, but that doesn't mean you need to make an entire class with multiple layers of inheritance just to get the length down. Deep dependencies like that are difficult to maintain, difficult to debug and reason about, and can often add dead code that's not actually needed. The goal is to make your code flexible enough that you can add to it or refactor as needed later on, but not to take every feature as an exercise in designing an overly abstract, convoluted architecture that may never be required. I will probably discuss this point more in depth in a later video, but here's a few questions I like to ask myself when figuring out what I need. First off, what features are required? These are the things that need to be prioritized in the design and can help really inform what I'm going to do. Next up, what features are reasonably likely to be needed? This could be something like an optional game mode I want to add if time allows, a new feature that's still in the prototyping stage, and so on. I'll keep these features in mind when coding, but their inclusion can't override what I know I need, and I won't take much time or effort to support them until I know I need them. This is the situation to pick the low-hanging fruit. Parameterize a function, create an enumerator to represent different configurations, etc. These are small things that aren't going to be a lot of effort to implement, they're not going to muddy up my code, but they'll help make it just a little bit easier to implement the new features that I'm kind of anticipating possibly happening. And the last question I'm going to leave you with is, what's the scope and impact of the code? High impact code, such as the structure of a level, should get more attention than code that is low in both scope and impact, such as the callback for a specific function on one menu that will never be reused. Remember, simplicity is often the best choice.